Hi roboticist! In the last video we have learned how to tune the PID controller for our joint position controller, and we have done it for the joint 1 position controller and the joint 2 position controller. And the robot model that we have controlled was made by 3 links: the base link, the link 1 and link 2. So now what we're gonna do is to add another link, so the link 3, and first we are gonna see if this affects the PID values of the previous joint controller. And if it doesn't affect nothing, what we can do is to tune the PID controllers for the joint 3 position controller, that I remember you is the joint responsible for making a revolution of the link 3 along the edges of the link 2. So let's do it right away. The first thing that we need to do is to update our cobot URDF file, and we need to include the link 3 and the joint named link 2 and link 3. Then, since that we add another joint, we need to uncomment the transmission for that joint. That's gonna be link 2, link 3. So we are generating the motor for the link 2 and link 3. Then, of course, we need to update our joints controllers YOM file. So it's gonna be our configuration file for the joint that we want to control, and we can create the joint 3 position controller, and we can keep the type as the same, so effort controllers joint position controller, and of course we need to change the joint name link 2, link 3. And finally we need to update our launch file, and in particular we need to update the arguments of the controller manager, like I'm doing right now. So everything is ready, we can launch the simulation. And you can see that now the third link, so the link 3, is spawned correctly in the position where we have set in the URDF file. So take a moment for configure better the GUI in such a way that you can see the windows and the simulation as well. As you can see, when you press play in the simulation, the robot stays straight, meaning that all the controllers are correctly set up. But we are going to check it using the method that we have seen in the last video, where we have used a plot to see the behavior of the command topic for each joint with respect of the status process value. So now we need to add to the topic the joint 3 position controller command. And then as an expression, let's start with the 90 degrees, and you can see that is acting correctly. Let's try minus 90 degrees, so minus 1.57 radians. Press enter, and you can see that even if the third link is moving, all the other links, or better, the other joints, are not moving anymore. So this means that the moving of the link 3 doesn't affect the joint position of the previous joint of the previous motor that we have set, the joint 1 position controller and the joint 2 position controller, meaning that the PID values that we have set up in the last video are good enough to overcome any misalignment on the position that might happen for inertia when you move only one link and keeping stable the others. What you can see is that when the link 3 is going to the 90 plus 90 degrees, the link 2 is slightly following the direction of the link 3, meaning that probably we are going to add an error between the command and the process value of the joint 2 position controller. But as a first guess here, for tutorial purpose, we can keep just as is. So now what we can do is to check the error between the command data topic and the state process value topic. So in the plot section, at the tab of the topic, just type cobot slash the name of the joint that we want to control, that is gonna be the joint 2 position controller that we have set in our configuration file, then slash, then command, and then the data. And this should be at 0. Then add the joint 2 position controller state process value, that is going to be 0, and we can check what happens to this value when the link 3 is going to plus 90 degrees. We can see that the position of the joint 2 position controller is kept at 0, meaning that the fact that the link 3 is moving doesn't affect the controller of the joint 2 position controller. So now what we can do is to add the joint 3 position controller command data that is popping up at light blue color, and then plot the state process value. And you can see that these curves, the light blue and the purple one, are overlapped. So meaning that the errors between the command data and the state process value of the joint 3 position controller can be negligible. So this means that the PID values that we have set as a first guess in the YOM file can be considered as good. So now we are gonna make something funny, and we can make the joint 2 position controller oscillate as well, in a sinus manner. So but this time with the amplitude of 1 radians. So you can see that the whole robot is rotating along the longitudinal axis of the base link, and you can see that these values are overlapped. So then we are gonna do the same for the joint 2 position controller. So tip the windows, and now you can see from the plot that even the joint 2 position controller, the command data and the state process value are overlapped as well, even if the joint 3 position controller is oscillating as well between plus and minus 90 degrees. So this plot shows you that the PID values set up for the joint 2 position controller and the joint 3 position controller are correctly set, because the moving of one doesn't affect the precision of the other, and vice versa. So we can challenge the PID values. So open the dynamic reconfigure window, and we can put the proportional value to 1000. And we can see that this changement doesn't affect the errors between the command data and the state process value. So meaning that the joint 3 controller is reliable. So what we can do now is to change the velocity of the joint 3 position controller, and you can see that when you press enter, the command data topics is changing like it is a step, the values, and the process value with a certain delay will follow that command. So of course it's very difficult that the process value follows 100% the command data if we introduce a step as a disturb. But we can consider that the errors goes into zero, meaning that the two curves are overlapped again in a few milliseconds. And what we can do is to increase the speed of the joint 2 position controller as well, and see what's happened. You can see that even now there is a step, but the curves are overlapped again in a few milliseconds. So meaning that we have made a good choice in the PID values. So what you can do is also to challenge the values of the PID by introducing a lot of disturb in the command data of the joint that you want to control. So for example, if we increase again the speed of the joint free position controller, and but we can put the derivatives values of 100, so is increasing. You can see that the process values follows the command data, and it reach the target value in a few milliseconds as well. So the key takeaway from this video is that when you add a link to your model, is always important to check the PID values of the joint that you have modeled before, in such a way that the second joint that you have introduced doesn't affect the quality of the controller of the previous joint, and vice versa. And that's all for today. And if you like this video, subscribe to the channel and turn on the notification bell in order to do not miss the next video, where we are going to complete our robots. Thanks for your attention, and keep learning robotics with ROS.